My name is Justin Henderson. I am, as Conrad would say, a GSE triple digit, which basically means that he is my master and I am his slave because I was late to the game, right? Even Dave, you know, he's got it way before me. So, just real quickly, let's just get to the content. I am the author of 555, co-author of 455 and 530. Really, for me, it's just I love this space. I love doing what we do. I love all things blue team. So I do a lot of things where I try to focus on just different approaches to things, like Freak Server, as Conrad was talking about. Like, it's a problem that needs solved, but we don't need to make it overly complicated. So there's fun little ways we can grab something, figure out that it works, and then integrate it. So I like to do a lot of things with that. I do a lot of like Docker projects on GitHub. I'll throw the link up here again at the end, because I want to make things easy for us to play with. And it's really weird, but the more that we give back, people make your stuff better. And then it's this vicious cycle of pure awesomeness. If you guys have kids, you've probably seen Kung Fu Panda. Like, it's so awesome, I'm blinded by the awesomeness. Right? That's blue team, right? At least for me. So apologize if you don't have kids, just run with it. So what we're going to talk about is kind of a different approach to logging. I wanted to do something kind of, I don't want to say thought-provoking, but practical, because I feel we often get these challenges and these tasks that we try to solve, but we end up fixing a problem rather than solving a problem. And so what I want to cover is just some out-of-the-box thinking and logic on how we can do different types of collection, as well as doing some really fun detection techniques that we otherwise couldn't do. And really, I'm going to focus on log collection, alternative ways to pick up our logs. And if you get to know me or you've seen any of the talks I do, I kind of feel like SIM is a little misrepresented. Like, log collection is boring, lame, and a bunch of other fun words that I won't say, right? It's not just about collecting logs. It's about making them have context so that we can do things like false positive reduction, so we can have detection techniques we otherwise couldn't do. And I refer to this as log enrichment. It's basically collection where you're getting context onto your log. And there's multiple ways of doing that. So when we talk about this unconventional collection methods, I'm also going to talk about a fun use case on taking logs that are craptastic and turning them into something that is really helpful and useful. So, okay, and then the second part we're going to end with is how can I use the similar logic to do some really fun detection mechanisms that work across any SIM platform. Like, I don't care whether you're doing a curator, logarithm, Splunk, Elastic, I don't care, that it's more specific to your endpoints. It's kind of outsourced detection if you want to, except for you're not charging for it, right? So, okay, let's dive into this. In a modern environment, this is kind of the traditional deployment. Like, we've got our SIM on the right, we've got our systems on the left we're collecting logs from, we've got log agents. Well, we have log agents for a reason. Let's say that's like a web server. IIS, Apache, I don't care. You have an agent because you're collecting operating system logs, such as Windows, and you're collecting files because of the application. But agents aren't free. Like, either you have to pay per SIM because it's commercial, or even if it technically is the agent's unlimited, you have to deploy and maintain it, and there's politics. How about this one? System's running slow, it's your agent's fault, right? Yeah, so what ends up happening? You keep the agent forever, right? No, it keeps getting disabled, you uninstall it, maybe you try a different agent, but then when you try a third-party agent, your SIM's like, we don't parse third-party agents, right? So this traditional environment isn't always possible, even though it might be an optimal configuration. So what ends up happening is we switch from this and we do hybrids or these off-the-wall things. Probably the most common I'll see is switching from an agent to something like Windows Event Forwarding. But this is one of those things where you fix a problem, but you're actually causing another problem. I love Windows Event Forwarding. It helps politically. This is the whole thing of, I don't want to deploy agents because people blame them for being slow or whatever reason. So now I'll do something like built-in syslog ng, rsyslog, Windows Event Forwarding, which is where we lie and we say, yeah, we're not deploying an agent. all right? And really what it is you're turning on a service, you're running it, it's a piece of software, it just was already there. This solves the thing where we can get the native operating system logs, right? It's a good thing, it's a step up. It solves hurdles, but it introduces new challenges. How do you get the files? So you have an IIS, you have an Apache, you have something that's logging to disk as a file, not in, like an EVTX. Windows Event Forwarding does not pick those up. It's Windows. syslog-ng and our syslog, we could tune those, but we have this challenge of we fixed one problem, we've introduced another, and now I have to solve that. So there are some things we can do to solve this that are kind of fun. We'll start with simple stuff and we'll go farther. I'm going to start with this concept I call a blind drop. When you drop off mail, you pull up to the post office and you put the mail down into the post office box. When you do that, can you be like, oops, I forgot to send grandma additional money, right? And you just kind of reach your arm down in there, right? And then you're the fool that gets your arm stuck and you still don't have it. And you probably go off to jail because it looks like you're trying to steal everybody's mail. Well, that's because you can insert, but you can't modify and you can't see it. I love this as a way to get rid of some of the agents. I call it a blind drop box. This is you set up a centralized file server. Maybe it's Samba, maybe it's FTP. I really don't care what it is. But the goal here is you set it up that someone can write logs to it, but they can't read or modify it after the fact. And then the concept from here is, instead of deploying agents on thousands, tens of thousands, hundreds of thousands of systems, you just deploy it on one box. Or you write a script on that box and it ships them off. So kind of as a sample use case here. PowerShell. So Conrad spoke about PowerShell logging, script block logging, module logging. Those are great. Those log to Windows events. You can Windows event forward those. Those are fantastic. We can do long command lines. We can do look for encoding, all sorts of fun things. But they don't show output. Like you see what was ran, but not what was output from those commands. So you have something like get dash everybody's password, and they hit enter. Did it work? That's what I would name my command, that, by the way, right? So I want to know if that worked. So you enable transcript logging, which is to a text file. Uh-oh, Windows Event Forwarding, if that's you, you don't have that log. So what you could do is set up that central file server, have it with write-only permissions, and you'll notice the top of this, where you see the share, that's what the user would see if they were to browse out to this. So they don't see anything at all. But if I jump on the actual server and I bring up the folder, the PS logs folder is what I named it, I can see everything and the transcript logs are there. Again, you could deploy a single agent on that box, and now you have those logs. Or maybe you're not collecting them into your SIM because they're for incident handling and forensics. It doesn't matter, you now have the options to do that. So there are multiple use cases for this. Could be that your applications literally write to a UNC path. Now you don't deploy an agent on all those. How do I deal with thousands of web servers all logging to one share? You make sure the folder they're logging to is their name. Right? It's just thinking of a different way of doing this. Because now you could have shares specific to applications, so your parsers work because they know based on the folder name what they're doing. So different concept. But let's keep going farther with this. SIM is not really about collection. It's about analysis, right? We collect logs for a reason. We're trying to solve the problem of, did someone do something they shouldn't have? Whether that's accidental, intentional, or otherwise, we're trying to catch the adversaries and do fun stuff. But if it's about analysis, why do we accept such poor quality logs? And I'm going to give an example of AppLocker, which I'm a huge fan of because we tend to own it. If you have Windows Server or later, this is baked in. It's fantastic. It's whitelisting for free. But the logs are good, but they can be better. As example, we see the AppLocker block event on the left here, right? We've got sec55 rocks, because it clearly does, by the way. That's my class, right? Jay Henderson, Paul, yeah, laughing at it. Yeah, I see how it is, right? Thank you, Kevin. He's biased, right? He's wearing a kilt, right? Thank you, Kevin. That was my request for 2 years. You finally did that. The log, the message of this says, OS drive sec55rocks.exe was prevented from running. Well, was that digitally signed? What's the hash of it? How about some fun stuff like, where did that file come from? Oh, wait, no, that's the analyst's job. No, that to me is the SIM's job. Like, I don't understand the manual analysis. Like, if I know that I get this in, I'm going to correlate over to this to figure out, oh, sysmon, this downloaded here because the hash is here and the hash is here, boom. Well, if you know that's what you're going to do, let's automate that. Or how about this? If you have a sandbox, like a Forta sandbox, a FireEye, a Damballa, why don't we take this and actually submit the file over to it and let it run in the sandbox and see what happens? Will that always work? No, it might have extra files it needs. But if someone downloads an exe to the user folder and they run it, like, why don't I get this context on the log? And the answer is you can, and I'm going to show you how to do it in a SIM-independent manner that should scale fine, and you can pull this off. So let's take the log, make it better, because then we can do false positive reduction or actually detect things quickly. Whitelisting, if you don't have like a 4-hour response time, good luck having a successful whitelisting project. This helps you get there. And it applies to more than just this context. This is just, I want to give you a use case. So, okay. When we get the context, traditionally, you do so in one of three manners. By the way, I'm just going to go out on a limb here and say that I'm going to guess 75% of you are not doing log enrichment. And that means automatically upgrading your logs with your SIM itself. So, example, log comes in. Let's say I have that app locker, event ID 8004 comes in. I could, when it hits, literally say, oh, I have an event ID 8004 from app locker, auto pull in the details from DNS and sysmon that have fields related to this and append it to the log. That's log enrichment. Hits your desk, it's already got the details on it. It could be that I do something when I'm viewing the log, it pulls either the data in or it just shows them overlaid on top of each other. Many SIMs allow you to do that at the time you view it. It could be you have orchestration software, and it's basically launching and doing all these things for you because you're automating that manual analysis. So there's kind of three traditional ways to do this. I'm introducing a fourth. Ideally, if you have all three methods, use all three methods. I'm not saying this replaces them. This is just an added method to do it. Because here's the problem. If I can do enrichment during ingestion, search, or orchestration, those are all tool specific. You switch from one tool to another, you now have to refigure out how to set everything up. And in some tools, it's easier than others. In others, it's really difficult. So what I'm going to show via this app locker example is, how could I make it, regardless of any tool I'm using, that this still works and applies? And I'm going to use one of the most advanced tools in the world. Ready? It's called Windows Task Scheduler. This is mind-blowing. Did you know Windows Task Scheduler has not just like hourly, daily, it has an option that says when an event ID occurs, do something. So as an example, here I'm creating a basic task. I really want to rename that to advanced because it's way cooler, right? And I'm saying, hey, go in here when a specific event is logged, AppLocker 8004, kick off a PowerShell script. Don't try again later. Do it now, right? So in here, you put a custom script on your endpoints or on a share. When event ID 8004 is triggered, a PowerShell script is ran, or a Python script is run. I don't really care. I like PowerShell, but I really don't care. Now, when this triggers, now what happens? Well, whatever you want. Example of some of the things I have. I have this running in a production environment, so I know this works, I know this scales. First thing it does is it pulls up the most recent 8004 event. So if you're not tuning at all and you're generating thousands of blocks a second, this won't work, but you have bigger problems, right? This needs to be, you've already gotten it down a little bit, and now 8004 triggers, it shouldn't be happening every single second. It triggers, it grabs the most recent. Now it has the path in the file, OS drive, sec555 rocks. From there, I'll do things like run sigcheck from sysinternals. That'll get me the metadata about the file. It'll get me virus total if I want that information. It'll get me the digital signature information, hashes. But why stop there? Like sysmon. Sysmon process creation, event ID 1. That gives us hashes, imp hashes, all of that. Parent process. So not only what is the file being ran, but what process tried to kick it off. But again, why stop there? If I have the hash of the file, I can look up the hash in sysmon event ID 3 network. Now I can figure out what process downloaded, how did the file get on the box in the first place. Will that always work? No, but if it does work, it's context. This came from Internet Explorer. This came from Word because it was downloaded via a macro. That's good information to know. PowerShell pulled this down and then it tried to execute it. Could be, maybe you just take the binary and you throw it into like a malware sandbox. Now that takes minutes to process. So if you have your SIM wait on that, your pipeline will just go, right? But if I'm outsourcing this to the endpoint, I can just wait for that analysis to finish. So now I have, here's what that executable would have done. Here's the chances it was evil. And again, you went from some really basic information, maybe, say, 8 fields, to now you might have like 30, and analyst looks at this, and they can immediately be like false positive. Or, oh my gosh, I really need to do something about this. Things like the DNS analysis that Conrad was talking about. All that, well, if I pull in sysmon event 3, I actually have the DNS name, and I have all that information as well. But it's automated, and it can scale because each endpoint is doing it themselves. Can you guys see where this would make analyzing an app locker event a lot easier to deal with? But the last step is the kicker here, is after doing all this analysis, write a new event. Generate a custom event. Because with PowerShell, you can do that. So you grab all the details, including the original app locker block stuff, and you append it back into its own special event. And I do event ID 31337, right? This is the elite event. This is cool. With PowerShell, you can create your own channel. I have one called Log Campaign for custom logs. I'll show a script I'm gonna share with you here at the end. And basically what it's doing is it's taking whatever data you want and you make your own logs. If you're not deploying agents, you're probably doing Windows event forwarding. This works with that. If you're doing agents, well, this works with that too, because it's native Windows logging. Now, this is PowerShell or Python though. I could also just send it as syslog. Like, you choose your destiny here. So I can take a log that still is a good log, make it severely better, and then make that a different event that my SIM will handle, regardless of tool here. Okay? So all right. Here's what the PowerShell log would look like in Event Viewer. So you can see it's got its own little log campaign channel, and we can actually read the log. In this case, I just goofed off and showed an example. This just says, new and improved log goes here. We'll talk about different ways we can massage this, but again, it's the trick that you can do whatever you want with this. So I like this. There is the concept here, though, that what about the security ramifications of trusting your desktops, right? So I'm running sigcheck, I'm running virus totals, like I'm doing this on the endpoint, but the endpoint at this point could be infected. Well, first off, let me just kind of debunk this myth here. Even though the box isn't potentially infected, the data is still better than not, right? It's still better than where you were before. But two, what you could do is change how you do this. I'm going to be honest, in most implementations, I'll go ahead and let the endpoint do some of this analysis. Because the sandbox is still going to do its own thing. Yes, the malware could change the executable as it copies over. That's possible. What you could do instead, if you want to change this, is you could just generate an event that lets your SIM or some process, like the alert engines, find this and then reach over, grab all the data at once, and do its analysis centrally. And you can do that. So you kind of just pick your destiny here. The good news is, no matter what, though, this works even as standard user accounts. So like you want to write a custom event log, the channel has to exist. You had to have created that initially. but writing a log a standard user can do. You want to send something via syslog, you can do that as a standard user. So you don't, admin access is not required. This doesn't have to implement a bunch of danger concepts here. So pick where you're going to do the analysis, hybrid it, do both, it doesn't matter. Okay? All right. Here's an example of doing the syslog. With PowerShell, you've got a massive 3 lines of code. Install a module for syslog, posh-s syslog. Go ahead and import it in, and then send the log. This is great for many sims still use syslog, which kind of drives me crazy. I won't get into that. We can talk about that later, right? Logging 101, don't use syslog. Kidding, you guys are stuck using it. If it's easier for you to consume the log via syslog rather than Windows event, there you go, send it with syslog. Python, same thing. Bash, the point here is if you want to do a custom log, this is not rocket science. This is simple stuff. Does anything I showed from writing a log look really hard and outrageous? The difficulty is more figuring out the logic of what you want to do. Like event ID 8004, what am I going to do to append that context? That's the hard part, and even then, that's not that hard. So just apply different logic here. The other trick I like is if your sim supports it, use a format that requires no parsing. You're generating a custom log. So we're invoking something like PowerShell or Python at this point. When we do that, we can make our lives easier because we control the output. We'll go back to the app locker event. I bring in an app locker log. It has all that details. I append additional data to it. And then when I write it back as a syslog message or as a Windows event log, just put it in a format that's easy to use. If your sim supports Ceph or Leaf, use those. If it's key value pairs or JSON, go for it. At a minimum, use something like a tab-delimited CSV. Just write it in a way that you're minimizing how much work you have to put into it to get this to work with your sim. Because this will still work sim independent. All right. So at this point, we've covered some different collection strategies. We're going to finish with detection strategies, though. So just kind of recapping here, though. We got Windows event forwarding, which solves some problems but introduces new. We also have the ability to do advanced things like Windows Task Scheduler, pick up the log, rewrite a new log, do things like syslog, whatever you want. Don't forget the point about reading it in and making it better, the enrichment pieces. Okay? All right. But there's one other thing we can do with this. If I have the ability to write my own logs, that means at the endpoints I can do some really crazy off-the-wall detection. That might actually be simpler than with your sim. I'm not saying replace your sim components. I'm just saying some techniques are easier to do if you have people that do PowerShell or Python local. So think about it like this. Adversaries use PowerShell against us. They use Python against us. They use Bash against us. So the gut check response is, turn it off. And that's like one of the major sins of this world. Don't turn it off. Tune it, make it work, use it yourself. As cyber defenders, we need it for hardening, but we can also use it for some really cool off-the-wall detection campaigns. And with that, basically, I'm going to show a custom framework I've designed specifically for the summit that is a framework for writing detection campaigns that you just do on a frequently occurring basis. Could be something you do with Task Scheduler every 5 minutes. Could be a Python script on Linux that you're running with cron. Or my personal favorite is you have the scripts that you design operate with their own scheduling. So they could be real time, they could be minute, they could be whatever you want. Okay? So with this, here's what I've got. I've got a project, I call it Log Campaign. I call it Log Campaign because you're running different detection campaigns or you're doing weird file ingestion. I'm going to focus more on the top part, which is basically saying, what kind of detection technique do you want to kick off? But the bottom part's also fun too. So basically this will allow you to ingest files. So we have text file, CSV, JSON, and it will try to automatically figure out the format. Like, is this pipe delimited, tab delimited? Like, what is this? Read it in and then output it via Windows log or syslog. So it's kind of cool from picking this up, shipping it off in a different way. We already talked about that. That's boring. Collection's boring, yes? I'm already dead and you're boring me back to death, right? That was my favorite commercial. All right. I want to focus now on the detection side, though. So in the top here, you see me running campaign ARP cache, and then I output it either in syslog or as a Windows event. Because I'm running this on the endpoints, I can start to do some fun stuff like, how about this? ARP cache poisoning? ARP cache poisoning. You know, that's that old school pen testing technique that just still works. If we're not doing things like private VLANs, host-based firewalls, things like this, then lateral movement still works all day long. I get on a box, I tell the box right next to me, my neighbor, hey, your gateway, you're looking at him, right? It's me. And I basically change the MAC address for the gateway on your system to mine because ARP has like no security built into it. That still works in 2018. But detecting that, well, the ARP, the MAC entry of your default gateway, that's changed. So think about this. What happens if you had this running? You had something running every minute or however often, and all it did was say, the first time I run, I'm going to record the MAC address of your default gateway, and then every time after this, if it changes, generate an alert. Now, how hard would that be to write? ARP-A, and then basically diff the results. Compare object or diff, right? So one module that I have in this sample campaign is that. It basically, the first time it runs, it records the MAC of your gateway, and if it changes, it sends off the result. Now, you switch out your router. What happens? Alerts everywhere. So, technique won't work. This is junk. Justin, why do you teach this stuff? No, if everybody's alerting, that's normal in this case. It's kind of long tail analysis. I change the router, I get all these alerts for everybody, who cares? But if I get that onesie twosie outside of me doing a hardware refresh, man, talk about a cool, quick technique to find this. That's simple to do. So with this tool, this log campaign PowerShell framework, I basically have this modules folder. And in there, there's a PowerShell script per campaign. So the first one I showed was arpcache.ps1. And the concept here is if there's anything you want to look for, you write it as a PowerShell module, you drop it in the folder, and now you can natively call it with this framework. Same thing, different approach. Autoruns. Autoruns is the way that we can find persistence mechanisms, right? You open this up, and I can say this piece of malware could rerun because it says a registry key. Maybe it's a Windows service. Maybe it's baked into a driver or DLL that's loaded. But the problem with autoruns is the output is like humongous. There's the command line edition. And I've seen some shops that they'll run the command line edition of Autoruns SC. They'll output to a file, and they'll feed that to their SIM every day. If you're doing that, kudos to you. You're a step above many organizations. Because now what you can do is, where is this system that is not running this one entry I found on this desktop? And you can investigate that. But a different approach is, again, run that as a module. This could actually run every minute or every 5 minutes. And again, what you do is you output the autoruns, and you diff it. So if you run this every 5 minutes, it shouldn't be generating logs. Until you installed something new or a piece of malware gets launched, it adds a new entry, that gets shipped off, just the new entry, the diff. So now I can take something that normally would have been an ad hoc experience, and I can make it near real-time-ish. I see one entry, oh, it's Google Chrome's updating piece. Okay, I've seen that across multiple systems, who cares? And you can bake into whitelisting, you can do whatever you want with this. So again, if it's scripting, you can do whatever you want. So now I can find this in the middle of the day. You deploy a new piece of software, tons of false positives, you can easily build that in, or just, again, you see 1,000 systems having it, that's normal. You can take this and apply this as a baseline tool across many different use cases. Fun stuff I've done with this. How about this? How many default gateways should a desktop in human resources have? Can anybody figure this one out? It's a tough question. Exactly, right? Did they plug their phone in? Well, you plug it into the phone to charge it, you still should only have one route, unless you're tethering off of it. So a third campaign that's in the sample repository is a dual home host. You have human resources, they're tethering because they want to watch Netflix or be on Facebook, but you don't allow it. That'll detect that. It's not like you have like $500,000 of controls like next-gen firewalls and FireEyes and stuff like that are being bypassed. Like, it's not that big of a deal, right? Yeah, come, you guys, wake up. Yeah, that's a problem, right? So we could use things like this to just find, like, do I have desktops that have multiple routers? I'll look at that. Certificates. Do you actually know when someone installs a new trusted CA? Most environments do not. And I get patching will change that, but that's en masse. You get one box that has a new trusted CA, that's malware. When they browse out to a site, it looks as it's trusted, but it's not. So make that a campaign. Ship that log off only when you see that, and you could run that such as every minute, and you would be fine. So this is kind of the different use cases that I like to apply this concept to. And you're doing this in a SIM-independent, neutral way. All right. The other thing I baked into this is, yes, you can kick it off with things like cron or task scheduler, but it also can have its own scheduling. So here I'm doing schedule 1, which is saying it runs once in the morning, like when you boot up a machine, it gets kicked off, and now it runs every minute. So then you could say I want to run maybe the route, the ARP cache, the dual home, run that every minute. Maybe I only want to do Autoruns once a day. In truth, I tend to do campaign all 1 minute and just run it all the time. Unless you have a custom module that is resource intensive and slows down the pipeline, but even that, you could schedule it as its own unique entry. So, again, when you're scripting, the world is your oyster, okay? So, all right. When we're doing this, effectively you're doing things like looking for stuff that's bad. ARP cache, dual home host, that's all that was. I'm basically looking for a condition that should always be one way, and as soon as it's not, I'm generating a custom alert. Some of this is going to be anomalies. Autoruns, I'm just diffing that, and when I see a change, that's kind of just a low-key anomaly. It doesn't, as its own, mean evil, but it's a smaller data source when I'm doing it this way, and it's just an anomaly I might want to look into. Because we're doing this on the endpoints, though, you could also do some really cool alerts on change monitoring. Change control is boring, we don't like it. But it is important. Consider this. I have a system in a DMZ. It's running Windows IIS. It is not doing authentication at all, right? It's just maybe your public website, right? So you go to publicwebsite.com, it's browsed off IIS. But because it's in the DMZ, it's more likely to get compromised, and in this case, it got compromised. But when the adversary was on it, yeah, this is boring. Like, we can deface it, but we want to use some more evil things with it. What if they just changed it from anonymous access to basic access or Windows access? What would happen? Think about this for a second. Let's say it's your corporate website. It's normally anonymous access, and I come behind you and I flip it to basic. Your users browse to the site, and it pops up a login box. What do you think a standard user is going to do to that? Oh, well, da-da-da. So adversary does this for a whopping 10 minutes, and they probably have like 50 credentials because it's a public-facing DMZ site that you don't care about. I mean, you do, right? But that's a risk factor that we didn't anticipate, but it's misuse of that. So what I could do is have a module in here that says dump out the IIS's configuration and send an alert if it's changed. If there's a change control ticket and that XML file that gets generated is different, that's normal. In fact, you could PowerShell script that to see if there was a change control ticket for that asset. If there's not, why the heck did this happen? Now, most of the time, that's going to be your IT folks shotgunning it, like hot rodding it. Change control, who needs this? Right? But you still want to know that too. That's how bad things happen. It's a bad posture. So think outside the box here, because we can apply this in many, many different ways. So I promised I'd show the GitHub link up here. This is where that project is. This is maybe 200 lines of code max. Like, it's not very big. It's not like I'm really not a PowerShell expert. I find weird things to do simple things. So you could take this, rewrite it in Bash, Python. You could submit your own modules. As one gets better, we all get better. And hopefully you guys saw some really cool ways to do some unconventional tactics here. With that, we have our morning break. Coffee and snacks will be out there. And yeah, any other notes we need?
Nope, I think that's it.
All right, so we're on break.